Welcome to Synapse Daily. Today, we step back to 1964. The Cold War is freezing. The space race is boiling. While the world watched the moon, NASA engineers were dreaming much bigger. They weren't just thinking about a landing. They were thinking about living. This is the story of the Integrated Modular Space Station. Imagine a world where the ISS doesn't exist. Instead, look up. You see a cross-shaped silhouette against the stars. It is massive. It is rotating. In 1964, this wasn't science fiction. It was a formal NASA proposal. It was a 24-man station designed to conquer the physiological limits of space. Chapter 1: The Biology of the Spin, the Terror of Weightlessness. In 1964, space wasn't a playground, it was a biological minefield. Imagine being a NASA physician at the time. You are looking at the first Mercury astronauts, men like John Glenn, and you see them returning from just a few orbits with dizzy spells and weakened pulses. The fear wasn't just that space was empty, the fear was that space was toxic to the human form. Scientists whispered about space sickness as if it were a terminal plague. They feared that in zero gravity, the blood would pool in the head until the brain swelled. They feared that the inner ear, robbed of the downward pull of Earth, would send the mind into a permanent state of vertigo. This is why the 1964 Integrated Modular Space Station wasn't just a design choice, it was a survival strategy. The proposal was a defiant no to the limits of biology. By spinning this massive, 150-foot cross, NASA was trying to trick the human body. As an astronaut, you wouldn't be falling forever. You would feel the floor pushing back against your boots. That 0.4 g force was the invisible glue intended to hold the human soul together in the void. It was the only way to ensure that when we finally sent a crew to Mars, they wouldn't arrive as a group of paralyzed, brittle-boned ghosts. Chapter 2: The Architecture of the Four Arms, a Steel Cross in the Void. Close your eyes and visualize the sheer scale. We are talking about a structure the size of a city block, floating 250 miles above the Earth. This wasn't the flimsy, gold-foil-covered craft we saw in the lunar landings. This was heavy industry. The central hub was the heart, a motionless, silent cylinder where the stars didn't move. But from that heart, four titanic radial arms stretched out like the blades of a slow-motion propeller. Each arm was 15 feet wide enough for two men to walk abreast, a luxury unheard of in the 60s. Inside, the walls were lined with pale green padding and brushed aluminum. The air had a metallic tang, filtered through experimental charcoal scrubbers. In Arm A, you'd find the sleep pods. In Arm B, the galley, where the smell of reconstituted coffee fought against the sterile scent of the labs. This was the integrated part of the name. Every arm was a limb of a living organism. If one arm was hit by a micrometeoroid, the station could seal its veins, the air ducts, and keep the rest of the body alive. It was the first time engineers thought of a spacecraft not as a vehicle, but as an ecosystem. Chapter 3: The Saturn V, Riding the Fire to Build a City. To build this dream, NASA needed to tame the most violent machine ever conceived, the Saturn V. Imagine the scene at Cape Canaveral. It's not just one launch, it's a rhythmic pulse of thunder. The 1964 plan called for a serial launch campaign. The first Saturn V would carry the hub and the first two stowed arms. This wasn't a delicate operation. This was 7.5 million pounds of thrust lifting a modular fortress into the black. Once in orbit, the arms would unfold using massive hydraulic pistons, a sound of groaning metal that would echo through the hull in the silence of space. Subsequent launches would bring the outriggers, the fuel tanks, the solar reflectors, and the crew. Each docking was a high-stakes gamble. There were no computers to automate it. It was a man, a joystick, and a window, trying to guide a 20-ton cylinder into a socket while traveling at 17,000 miles per hour. One wrong move, one hot thruster burn, and the entire multi-billion-dollar dream would shatter into a cloud of orbital debris. This was construction at the edge of physics. Chapter 4: Life Inside the Machine, the Sound of the Spin. What did 1964 sound like in orbit? It wasn't silent. The Integrated Modular Space Station was a cacophony of ambition. There was the constant, low-frequency thrum of the reaction control wheels, giant gyroscopes that kept the spin stable. There was the hiss of the nitrogen blowers. But most of all, there was the strobe. Because the station spun, the sun would flash through the windows of the galley every few seconds. Engineers actually worried about photic stimulation, the idea that the flickering sunlight would trigger seizures in the crew. Their solution? Polarized, rotating windows that could tune out the sun. Imagine sitting at a table, a real table, eating a steak that was flash frozen in Florida and thawed in a 1960s convection oven. You look across at your crewmate. You aren't floating. Your fork stays on the plate. For a moment, you could almost forget you are in the vacuum. But then you look at the floor. It's curved. The up direction is toward the ceiling, which is actually the center of the station. It was a world turned inside out. Chapter 5. The Space Tug, the Unsung Blue-Collar Hero. To assemble this modular titan, NASA proposed a vehicle that looked more like a forklift than a spaceship, the Remote Maneuvering Unit, RMU. In the 1964 blueprints, the RMU was the worker bee. It was a small, hexagonal pod covered in thruster nozzles. An astronaut would climb inside, peer through a tiny porthole, and use mechanical claws to grab the incoming modules. This was the birth of orbital logistics. The tug had to be incredibly powerful yet incredibly delicate. It had to wrestle the massive radial arms into position. Imagine the bravery required to pilot this. You are outside the main station, floating in a tiny glass bubble. Behind you is the infinite black, in front of you is a 50,000-pound cylinder of pressurized oxygen that you must guide into a docking ring with less than an inch of clearance. If your thruster sticks on, you become a human missile. These pilots would have been the most elite construction workers in history. Chapter 6. The Nuclear Option, Snap Reactors in the Sky. As we move deeper into the technical heart of the 1964 proposal, we hit a detail that sounds like pure sci-fi: nuclear power. Solar panels in 1964 were inefficient and fragile. NASA knew that to keep 24 people alive, powering their lights, their oxygen scrubbers, and their massive centrifuges, they needed more juice. They looked to the Snap 8 reactor. The plan was to extend a 100-foot boom from the bottom of the hub. At the end of that boom, far away from the crew's DNA, would sit a humming nuclear core. This reactor would provide 35 kilowatts of uninterrupted power for years. It would glow with a faint, eerie blue light in the shadow of the Earth. But this created a nightmare for the engineers. How do you shield the crew from the gamma shine reflecting off the station's arms? They designed shadow shields, massive lead and tungsten plates that would sit between the reactor and the living quarters. The station wasn't just a home, it was a radiation-balanced machine, a delicate dance between the power of the atom and the fragility of human cells. Chapter 7. The What-If Era Lost Mars Frontier. The 1964 Integrated Modular Space Station wasn't meant to just sit in Earth orbit. It was a Mars staging ground. NASA's long-term plan was to use this station as a gas station in the sky. Future ships, built in the zero-G hub, would dock here, take on fuel and crew, and then ignite their engines for the 2-year journey to the Red Planet. If we had built this station, the history of the 1970s would be unrecognizable. We wouldn't have just visited the moon, we would have used this spinning fortress to conquer the solar system. We would have mastered artificial gravity by 1975. The space shuttle would have been a ferry to this station, not a vehicle that spent 30 years in low Earth orbit with nowhere to go. Chapter 8. The Death of a Dream, Politics versus the Stars. So, why is this station a ghost? Why did we trade this spinning palace for the tin cans of the 70s and 80s? The answer is a cold, hard number: the budget. By 1967, the United States was bleeding money into the Vietnam War. At home, social unrest was boiling. The politicians in Washington looked at the 1964 proposal and saw a luxury they couldn't afford. They made a choice. They decided that low Earth orbit was enough. They cancelled the advanced Saturn V production. They mothballed the nuclear reactors. They took the integrated modular blueprints and put them in a drawer marked Future Studies. When Skylab launched in 1973, it was a shadow of the 1964 dream. It didn't spin. It didn't have 24 men. It was a use it and lose it station. The vision of a permanent, Spinning City died in a forest of red tape and budget cuts. Conclusion: the legacy of the 1964 Titan. Today, when we look at the International Space Station, we see the ghost of 1964. We see the modularity, but we miss the ambition. We miss the spin. The 1964 proposal remains a haunting reminder of what we are capable of when we aren't afraid to dream big. It reminds us that we once had the blueprints for a galactic civilization in our hands, and we let them slip away. But those blueprints still exist. In the synapses of history, the spinning cross is still out there, waiting for a new generation to look up and say, it's time to build. Chapter 9: The Anatomy of a Module, 15 Feet to Survive. Let's get surgical. To understand the 1964 Integrated Modular Space Station, you have to understand the standardized module. In 1964, NASA didn't want to reinvent the wheel for every launch. They designed a universal cylinder. 15 feet in diameter, 40 feet in length. Inside these aluminum husks was a multi-layered sandwich wall. The outermost layer was a thin meteoroid shield, designed to shatter incoming space dust before it could hit the main hull. Then, a 2-inch gap of vacuum insulation. Then, the pressurized skin. Inside that skin, every inch was utilized. This was the pinnacle of mid-century optimized living. The floor wasn't just a floor, it was a removable hatch system that led to the basement, where the liquid oxygen tanks and carbon dioxide scrubbers lived. The walls were utility spines, carrying miles of copper wiring and plastic tubing for the water recovery system. In 1964, they were already planning to recycle 80% of the crew's sweat and urine into drinking water. It sounds gross, but in the silence of the void, that recycling system was the difference between a thriving colony and a floating tomb. Chapter 10: The Secret Surveillance, a Fortress in the Sky. We have to talk about the elephant in the room. It was 1964. The Cold War was a game of shadows. While NASA was a civilian agency, the Department of Defense, DoD, was watching this station proposal very, very closely. One of the radial arms, Arm D, was often vaguely labeled as experimental Earth observation. In military terms, that meant the ultimate spy perch. From a rotating station with high-resolution telescopes, the US could have monitored Soviet troop movements, missile silo construction, and submarine departures in near real time, 24 hours a day. Imagine the optics lab in Arm D. A massive telescope, perhaps 100 inches in diameter, looking down through the spinning windows. The engineers had to solve a nightmare problem. How do you take a clear photo of the ground when the camera is on a station spinning at 6 revolutions per minute? They proposed a counter-rotating mirror system. As the station spun one way, the camera's mirror would spin the other, locking onto a target on the ground for a fraction of a second to snap a crystal-clear image of the Kremlin. This station wasn't just for science, it was potentially the most powerful weapon in the Cold War arsenal. Chapter 11: The Galactic Gas Station, Fueling the Mars Convoy. NASA's 1964 dream didn't stop at Earth orbit. They viewed this station as the port of call for the nuclear thermal rocket, NTR. At the time, NASA was testing the Nerva engines rockets that used nuclear reactors to heat liquid hydrogen to insane temperatures. The plan was this. The integrated station would serve as the assembly point. A massive Mars-bound ship would be parked at the central hub. Small space tugs would ferry fuel tanks from the station's storage to the Mars ship. By having a permanent, rotating base, the Mars crew could spend their last few weeks in simulated gravity, keeping their muscles strong before the long, weightless journey to the Red Planet. The station was the psychological anchor. It was the last bit of Earth-like feeling an astronaut would have before disappearing into the black for 2 years. Without this station, a Mars mission was a suicide mission. With it, it was an organized expedition. Chapter 12: The Emergency Protocols, Fire, Vacuum, and Madness. What happens when things go wrong 300 miles up? In 1964, NASA engineers wrote the Book of Disasters for this station. The most feared scenario was a spin imbalance. If one of the modules leaked air or if a docking went wrong, the station's rotation could become wobbly, a phenomenon known as nutation. Imagine the entire 150-foot structure shaking like a dying top. To fix this, The hub contained massive balance tanks. Computers, which in 1964 were the size of refrigerators, would detect the wobble and instantly pump water or fuel from one arm to another to rebalance the center of mass. It was a mechanical ballet, performed at thousands of miles per hour. And then there was fire. In a spinning station, fire doesn't behave like it does on Earth. The centrifugal force would pull the smoke toward the outer walls. The crew was trained to run to the hub. The central hub was the only place where the air could be completely isolated. If an arm caught fire, the crew would flee to the zero-G center, seal the blast doors, and watch as the arm was vented into the vacuum to starve the flames. Chapter 13, 1964 Technology, the Analog Future. We have to remember, they were doing this with slide rules and transistors. The computers on the integrated Modular Space Station would have had less processing power than the chip in your modern toaster. There were no touchscreens. There were no LED displays. The control deck in the hub was a sea of Nixie tubes, analog dials, and heavy toggle switches. Data wasn't stored on the cloud, it was recorded on magnetic tape reels that spun in the background. To communicate with Earth, they used massive parabolic dishes that had to stay pointed at ground stations while the station itself was spinning. The sheer mechanical ingenuity required to make an analog machine survive the digital vacuum of space is one of the greatest hidden feats of the 1964 proposal. Chapter 14, The Cultural Impact, From Blueprints to Kubrick. Did you ever watch Stanley Kubrick's 2001, A Space Odyssey? The Space Station V, that giant, rotating wheel? That wasn't just a movie prop. Kubrick and his team were in constant contact with NASA engineers during the mid-60s. The 1964 Integrated Modular Proposal was the scientific father of the movie's iconic design. When the world saw that spinning wheel on the silver screen in 1968, they weren't looking at fantasy. They were looking at what NASA had told the public was the next step. For a few years, the entire world believed that by the year 2000, we would all be drinking coffee in a rotating lounge while looking down at the Earth. The cancellation of this project didn't just hurt NASA's schedule, it hurt the human imagination. We were promised the spinning wheel, and we were given the flying brick of the shuttle era. Chapter 15, Final Conclusion, The Synapse Daily Perspective. As we close the file on the 1964 Integrated Modular Space Station, we are left with a feeling of hauntology, the idea of a future that failed to happen. We often think of progress as a straight line, but history is full of broken timelines. The 1964 station is a monument to one of those breaks. It represents a moment when we were brave enough to solve the gravity problem, brave enough to use nuclear power in orbit, and brave enough to build a city in the stars. Today, as companies like Blue Origin and Vast Space talk about artificial gravity stations, they aren't inventing something new. They are finally catching up to the geniuses of 1964. They are finally reading the blueprints that have been gathering dust for 60 years. Maybe, in our lifetime, we will finally see that glowing cross in the sky. Maybe we will finally hear the hum of the spin. Until then, we remember the dreamers of Langley. This has been Synapse Daily. You've just traveled through one of the greatest what ifs in human history. Like this video if you learned something new. Comment your thoughts below and subscribe for more fascinating stories.